All right, fourth degree polynomial. I want to find the fully factored form, and I'm given a 0 at I. Let's first graph this and see what it might look like. So here's the polynomial, x to the fourth minus 2x cubed plus 4x squared minus 2x plus 3. When we graph it, we see that we have no real zeros because it does not cross the x-axis. So they're all going to be complex. So we know we have 1 0 at I, so I could make a factor out of that, x minus the 0. But you know you have another one because you always have its conjugate pair. So the other 0 is going to be x minus negative I. So that turns out to be x plus I. What we want to do now is we want to multiply these together. And you can FOIL it out, or you can use the box method. When you multiply them together, you get x squared plus 1. Now what we want to do is our long division with these two factors already multiplied together. So x to the fourth minus 2x third plus 4x squared minus 2x plus 3. Notice I filled in the missing term here. Let's go ahead and do this division. X squared here, x squared times x squared is x to the fourth plus 0x cubed plus x squared. Subtract that. I have 2x to the third. 4 minus 1 is 3. Drop the second term. And we're ready to do this again. Let's see, this should be a minus 2 right here. We had a minus 2. There we go. So we need a negative 2x up here. Negative 2x times x squared is negative 2x cubed. And this becomes 0x squared. And this becomes a minus 2x. And subtract those terms. So I have a 3 minus 0, that's going to be a 3x squared. Negative 2 minus a minus 2, well that's going to be 0. So I have 0x, and I have to drop the last term, so I have plus 3. And we do our division one more time. We end up with a 3 here. 3 times x squared is 3x squared. 3 times 0x is 0x, and 3 times 1 is 3. And when we subtract that, we get a remainder of 0, which is what you expected because you knew that this polynomial contained the two zeros. So now we've got x squared minus 2x plus 3. And we want to solve that. Well, first of all, we know it contains complex zeros. So the easiest way to solve this is to use your quadratic program. A is 1, B is negative 2, C is 3. And when I run that through my program, or I do it by hand, I can do it either way. And so I'm going to get, if I do it by hand, let's go ahead and do this one by hand. Let's erase some of the stuff here and give us some room to do this one by hand. You, of course, could use your program. I just want to show you what it looks like when you do it by hand. Alright, so we have negative b, so that's negative 2, plus or minus the square root b squared minus 4 times a times c, all over 2 times a. Let's reduce that. So I have a 2 plus or minus. Alright, so 2 times 2, that's going to be negative 2 times negative 2 is going to be 4. 4 times 1 times 3 is 12, all over 2. And so underneath the radical, I've got a negative 8, and I expected it to be negative because it's complex, over 2, and I can reduce this a little bit. I've got 2 plus or minus, so 8 is 4 times 2, so I can go ahead and take out the 2, and square root of 2 all over 2. And then I can reduce 2, 2, and 2. And so I'm left with 1 plus or minus, oops, I have my negative there, plus or minus I times the square root of 2. And if you'd have done this with your calculator, you get 1 plus or minus 1.414i. Okay, so now I want to make my fully factored form. Let me do a little bit more erasing here, because this is really interesting. Fully factored form. Give myself a little bit more room here. Okay, fully factored form. F of x equals. Alright, so we know we've got a x minus I, and we know we've got a x plus I. Those are the two from the beginning. So my other two roots were 1 plus or minus I times the square root of 2. I'm going to leave it in that exact form. So watch how I do this. I've got x minus the 0. Well, there's two zeros here. One of them is 1 plus I times the square root of 2, and the other is 1 minus I times the square root of 2. So all I'm going to do is put that in parentheses. It's x minus the 0, and the 0 is 1 plus I times the square root of 2. And then the last one is x minus, I'm going to put it in parentheses, 1 minus I times the square root of 2. And there is my fully factored form with each of my complex zeros right there.